So in section 3.9, what we're going to really do is, we've already looked at linear functions, so we're going to really just look at applications of them. Okay, we're going to simply look at applications and what we can use them in. So the first one's going to be more mathematical, and after that we're going to get right to word problems for this. So for the first, you guys know this already. We talked about this last class. A linear function obviously is y equals mx plus b. What does f of x mean instead of y? What does f of x really mean? A function, good. A function of whatever x is. Very good. So in this case, it's really still y equals mx plus b. But y is a function of whatever x takes on. Okay, whatever it takes on. And the slope obviously is the change in y over the change in x. But instead of y, we have f of x up here at the top right. Okay, change in y over change in x. Example here says find the equations of linear functions h and k using the given information. So part A is for h, part B is for k. So we want to find these functions. From last class, you should be able to describe to me what part A is telling you. What information is part A giving you? It says h of 3 equals 2 and h of 5 equals 7. What is that actually telling you? Because it's not obvious what it's telling you. Can somebody take that and translate it into something a little simpler for us to understand? Jana?
In the first function, when x is 3, y is 2. And then in the second one, when x is 5, y is 7.
Yeah, so for the function h, right, for h of x, this is part A. For h of x, we have the points 3, 2, and 5, 7. That's literally what it's saying. And as what Chandler just said a moment ago, when x is 3, y is 2, so you have the point 3, 2. When x is 5, y is 7, so you have the point 5, 7. So really, when you're given a function's value at a given x, you're given a coordinate in the end. Okay, when you're given the function value at a specific x coordinate or x location, you're really being given a coordinate point itself. So given those two things, can we figure out what the function is? Very easily we can. What's the slope? What's the slope going to be for this?
2.5.
Good. 5 over 2, or 2.5. Okay, what else do we need? Do you need anything else, really? We could find the y-intercept, but we could also just solve for b. So let's go ahead and write this. H of x equals 2.5x plus b. We got to figure out what b is. How do I find out what b is? How do I find out what b is? Remember, this is really y equals mx plus b. Sarah?
Can you plug 0 in for x and then double b?
Can't plug in 0 because you don't know this over here, right? If you knew what this value was or something else was, you could figure it out. But if you plug in a 0 here, you're going to get b equals whatever this is, which is true, but you don't know what this is, right?
Okay.
You plug in one of the points for x and y.
Yeah, so look, you're told that when x is 3, h of 3 is 2. So this is 2 when this is a 3. Or this 7 right here, this is 7 when x is 5, when this is 5. So really, what Morgan is saying is plug in 5, 7, 5 here and 7 here. Or plug in 3, 2, 3 here, and 2 goes in for this. Remember, this is really y. If you're ever confused here and you're confused about what this means, this is the variable y. So go ahead and apply the point. Which point, it doesn't matter, honestly. It makes no difference. I'll use 3. Oops, I'll use, clearly not 3, I'll use 2. So I'm applying this point right here to that function. The 3 is the value of x, so that goes in right here for x. The 2 is the value of y, or h of x. Right, this 2 right here goes in right there. This 3 right here, I'll make the arrow more direct, goes in right there. So you're going to get 2 equals 7.5 plus b. Therefore, b equals negative 5.5. So your function for h of x is 2.5x minus 5.5. So this is really no different than what we did in chapter 3. Okay, remember in chapter 3, we looked at linear functions, y equals mx plus b, ax plus by equals c, y minus y1 equals m times the quantity x minus x1. It's really the same thing, except instead of y equals mx plus b, I have h of x equals 2.5x plus b, or minus 5.5. But this is still slope-intercept form. Okay, still slope-intercept form here. So that's part A. How about part B? Scroll back up. How about part B? Can somebody give me some piece of information from part B that you can write down? What does k of 0 equals 4 mean? K of 0 equals 4. What does that mean, Inigo?
Well, are they together?
No, separate problem.
Oh, okay.
Part A and part B are separate things.
Means that when k is 0, then wait, no. When y is 0, x is 4.
You sure? Remember, we're looking for a function called k of x, right? What takes the place of x in that first statement? Look at this statement right here. Right? And we're looking for a function k of x. So we're told that k of 0, not k of x, but k of 0 is equal to 4. So 0 takes the place of what? So when x is 0, go ahead. Yes, you said it backwards a moment ago, okay? So give me 1 second, just 1 more second. So you know that that's the y-intercept right there? And the second part, an increase of 5 units in x causes a decrease of 10 in k. What does that mean? I'm going to have you finish this problem tonight, so you might want to listen. What does that mean? An increase of 5 units in x, it causes a decrease of 10 units in k.
Is it x plus 5 equals k minus 10?
Jeff?
That means that a k of 5 is equal to 14.
No. Inigo?
Does it mean that the slope of the, I mean, it's not really slope, it's a function, but
Still slope, go ahead.
it means that it's 10 over 5.
Yeah, but it's going to be negative 10 over 5. This is going to be a vertical, there's a decrease of 10 units. So the change in y goes down by 10 when an increase of 5 units in x occurs. So this is really delta y over delta x. A change of 5 units in x produces a decrease in 10 units of k. Well, k is really like your y, k of x. So y goes down by 10 when x goes up by 5, change in y over change in x. So here's your slope, and here's your y-intercept. So you can just write your answer, k of x equals negative 2x plus 4. This is really your y-intercept. Okay? Tonight you don't have to do the homework for this section. There are some other problems we're going to do tomorrow. But if you want to get a head start, you can do that. Okay, so take a look at the beginning at least, the very beginning, and then the word problems, leave those blank. Okay, again, section 3.9. Look at the written exercises. Leave the word problems for now, please. So on a strength training test, a person scored a 140 on a scale of 0 to 175. Find a linear rule that represents this and use it to convert it from 0 to 100. Convert it from 0 to 100. Now, this is a really easy example. I can make this a lot harder with one simple change. Why is this easy as an example? Can some of you right away try to figure out how to get the answer value and get the rule? Like, how would you know what a 140 is on the scale of 0 to 100? How could you figure out what 140 is? It's a very easy way to do it without doing any of this function rule stuff. You can figure out. So your score is a 140, right? The test ranges from 0 to 175. What is 140 from 0 to 100? Like, what is it as a percent? How would you figure it out?
You divide 140 by 175.
Very simple, right? Take 140 over 175, that gives you the percent. If I gave you a test and it was out of 175 points, and you got 140, you could get your percentile score, which is what 0 to 100 is. 0 to 100 is a percentile score. Now, that makes this problem a little bit easy, so when we do the math, you're going to say, oh, we don't need to really do this. But if I made one simple change, such as changing the strength training test, and made that scale instead of 0 to 175, if I made it, like, say it ranges from 50, like 50 is the bottom out value for some reason, right? 50 is the lowest score you can get on the strength training test. Probably wouldn't make too much sense to start at 50, probably want to start at 0, but some things do start at values that are not 0. Now, if it's from 50 to 175 and you go to 140, your answer, you can no longer do 140 to 175. It's not the same percentile. You'd have to find some sort of a function that represents this. So let's do it for 0 first, and then I'll make that small change to 50 at the end and show you how it changes your problem very, very small, in a very small way. So we know right away that on the strength training scale, a 0 on the strength training corresponds to a 0 on the percentile scale. That's what 0 to 100 is. Let's call it a percentile scale because that's what it is. When you convert something to 0 to 100, it's like when you get your SAT, you get your, where they tell you what percentile you fall. If you're like 90th percentile on a math test, it means that you are higher than 90% of the population that took the test. And you're lower than how much? 10%. You're at the 90th percentile. Okay, so that's 0 becomes a 0. But on the strength training test, a 175 becomes what? What is that as a percentage? A 170. If you got a 175 in the strength training, where are you? 100%. You're the top. Okay, you're the top of the possibilities. So if you can get that 175, you have attained 100 percentile. Okay, whatever test it may be. Now, it says find a linear function rule and use it to convert this score to a scale from 0 to 100. So eventually, what you're going to do is you're going to plug a 140 into the rule. This is going to be plugged into the rule, so this is your input. And then you come out with to get a percentile. Think about it logically. You're going to take 140, you're going to plug it into whatever rule it is you make, and you're going to get out a percentile score. Now again, as Will said, just divide it by 175, you'll get the percentile, but we're going to make a rule for it, and it's the same thing as what you said a moment ago, actually. Okay? So we're going to plug it in and get a percentile. So we're plugging in 140. What does that mean? What kind of a variable does that make it? If you're going to plug in 140, what do we call that? Which variable type? We've talked about the types of variables you can have. There are two types, usually represented by x and y, but there are names for that, right? Is 140 going to be the x, or is 140 going to be the y? If you're going to plug in 140. Think about the quiz we just took. Think about evaluating functions. What do you plug in? If I want to do f of 7, what does that mean? It's going to be x. When I ask you what's f of 7, you take 7, as Emily said a moment ago, and plug it in for x. As James told us just now, well, 140 is the x. You're going to plug in 140 into some rule and come out with some value as a percentile. So as a result, that means that your strength training is like your x, and your percentile is like your y. So yeah, you could have mixed it up and done one as x and one as y the other way around, and you still probably would get the right answer, but the rule would be different. So it's important to understand what your input is. Your independent variable is x, or the strength training score. Your dependent variable is your outcome, or your percentile. Okay, your percentile, or your y, or your outcome. That's your dependent. So as a result, we've got two coordinates. First coordinate is 0, 0. The second coordinate is 175, 100. Here's your two coordinates. So again, what are we going to do? We're going to figure out a rule for this. Let's make a rule. So the change in y over the change in x is what we're going to look for here, right? We're going to think about the fact that when we plug in 175, we get 100 as our answer. Well, 0, 0. So our m value is going to be y over x. So our m value is simply going to be, in this case, 4/7. Divide them both by 25, reduce. That's our slope of our function, 4/7. Okay, 4/7. Well, that does make sense. Let's go into why that makes sense in a moment. So we've got the fact that we've got y equals 4/7 x plus some starting value. What's the y-intercept? You don't need to do anything. You could figure it out just by looking at the board. You don't need to actually do anything. What is the y-intercept? Anybody got it? Jeff? The origin. So what is the y-intercept? 0, 0. It's 0, 0 in this case, because the origin is one of our points. It makes it very easy. So what happens to the value of b? What's the value of b if I tell you that the origin is one of the points? Yeah, the value of b is just 0. So here's your rule right here. Here's your rule right there. And that rule actually makes sense. Will, a moment ago, didn't you say just take the number 140 and divide it by 175, right? Well, this, if you recall, is really 100 over 175, isn't it? Isn't that where that came from? So if we did what Will said, which said, you know what, just plug 140 in here and divide it by 175. That's what this rule is doing. But then the rule is multiplying by 100 to convert it to a percentile. Like you do with percent error in your biology class, maybe? Have you done percent error yet in your bio class or in a science class at some point? Percent error, usually you say theoretical minus the accepted over the theoretical times 100. That times 100 just takes something like 0.92 and it makes you write it as 92%. So really, look at this function. It's x over 175. That's what Will said. 140 over 175. That's your percentile. Times 100, which is in the numerator, which really just converts it to an actual percentile score. So plug in 140. So here's our rule for this one. Our percentile score is a function of the actual strength training score. If we want the percentile when the strength training is 140, we put in 140 here. We're going to end up getting, what, 80%? Okay, and our answer is just simply 80 because the units already are there. The units of percent are already embedded. We multiply by that 100 technically with this 4 here, and that 100 is taken into account. The answer is just 80. I would write my answer as 80 simply because it's an actual coordinate. And I called this a percentile scale. It wasn't actually called a percentile scale in the problem. It said convert it to a scale of 0 to 100. So on a scale of 0 to 100, a 140 out of 175 is simply 80. Now, what if the bottoming out of this scale again had not been 0, right? What if the scale, instead of going from 0 to 175, move this down a little bit, instead of going from 0 to 175, went from, say, again, the smallest score you could have gotten was 50. Well, that would have changed this, right? It would have made this 50, which would have made the change in x, instead of 175 as a change in x, would have been 175 minus the 50, which would be 125, which would make this 4/5, which would change my slope to be 4/5. And the y-intercept would no longer be 0. This would not be true, because the origin would not be one of your points anymore. The first point of the graph would be 50, 0. That's the x-intercept, right? 50, 0. You'd have to find the y-intercept, you'd get a different rule, and as a result, you'd have to apply that rule. You couldn't simply divide 140 by 175 if that lowest score wasn't a 0. Okay, so this problem happens to be an example where, sure, you could do that, and it makes sense to. But if you're trying to write a linear function, now you've got to figure out what it is. So you'd have to go with this. You'd have to apply a point. I would apply the point 50, 0, that new point that we have, because we're saying the strength training test starts at 50. I would apply 50, 0 into my equation like that, right? And I would solve for b. 4/5 of 50 is 4/5 of 50. Should be a quick one, right? What's a fifth of 50? So 4/5 of 50. This is 40. Mental math. Come on, people. This should be 40 right here. So b turns out to be, in this case, negative 40. So our rule, if we had a bottoming out score in the strength training test of 50, our rule would be 4/5 x minus 40. That would be our rule that we'd have to use if the strength training test went from 50 to 175. Okay? And think about it. If it went from 50 to 175, if you plug in any number less than 50 for x, you're going to get a negative answer. It means you got a negative score on the test. If the lowest score is 50 and you got a 40, That means you got a negative score, right? So if you plug in a number like 40 for x, you're going to get a negative answer. So 50 is the lowest score you can get. Plug in 50, you get 0. So if you got, like, say, 140, plug in 140 there. Tell me what you get. Plug in 140 into that scale, please. And tell me what percentile it turns out to be. So 4/5 times 140 minus 40. Thinking 75 by guessing. I'm just trying to do quick math. What do we get when we plug it in? Well, 72? I don't know why I was thinking 75, because I was thinking about, you know why? I took 140 and divided by 4, not 5, where it's going to be factors of 2, and I wrote 75, of course, jeez. Because I was thinking of 45, 45, 45, 45. That would be 180. So 72 is our value. Why is that less than the answer we got a moment ago? Make sense of your answers. Why did we get a number less than 87?
Because the boys are going to, like, each question is going to have a higher point value since there are less questions done.
Yeah, think about it. The score originally ranged from 0 to 175. And you got a 140, that's pretty high, right? And now you start at 50 and you only got to a 140, which is like you got less points, right? Because if you only got to 140 when it started with 50, you didn't do as well as if it started from 0 on the test score. So your score was less than in percentile than what you got originally. Okay, so it'd be a 72% score. All right, let's take a look at some examples of a function with domains. So the first one for us, Maureen, why don't you read the first one for us?
Follow it.
Just read it out loud.
A manufacturer of baseballs spends $3,000 on fixed costs per month and 50 cents for each baseball used. The total cost of producing X number of baseballs per month is given by.
Okay, that's what we're going to try and figure out, and then the domain after that. So work with the person next to you for a minute. Figure out what this could be. Come up with a function for this. And all these problems really don't require a ton of math to actually go through. Okay, Jeff, why don't you work with 3, and 2, 2, and Nico, do you want to slide it over here? Try to come up with your actual function, and then come up with your domain, though, please. The domain is important as well. The domain is restricted. There are definite restrictions on all these domains. If you get the first one, call me over. I'll take a look at it. Okay? Only about a minute left, so you're probably finished on this. You were talking about this. Did you even get through all of them? How far did you get? Look at yours. Did you come up with 3? Remember you were working with a partner and there was only like 2 minutes left? Did you get to like the first one? You want to figure out the next 2? Try to come up with the next 2. Take a minute or 2. Work with the person next to you around you if you want to. Just confer if you're having trouble. The second one and third one, the domain is probably a little bit trickier than the first one was. So we already came up with the first one. You can write that down, obviously. At noon, a pump started emptying oil from a storage tank at a constant rate. That was at noon. Okay, so that's like the beginning of time. At 2 p.m., there were 680 barrels left in the tank. Barrels is a quantity in volume. At 5 p.m., there were 600 barrels left. Write a linear function to describe the situation. How many barrels were there in the tank at noon? And what time will the tank actually be empty at? Try part A. Take a look and think about what you would do for part A. I'll give you a minute or 2 to look at it. Give me maybe a suggestion as to what we can do here. I'm going to do this in two approaches because I guarantee you we're going to have two different answers. So somebody give me one way they did this for part A. Give me one way, James.
First I found the slope.
Yeah, how'd you do that? What was the coordinates you used?
I had 2 and 1,680 and 5 and 600.
5 and 600. Agreed. Now, finding the slope between them, clearly what kind of a slope will it be? What kind of a slope must it be? It's emptying oil from the storage tank. What kind of slope? Negative, right? You got to think of the context first. So it's negative because it's the volumetric flow rate. It's going to be units of barrels per hour, right? Look at 2 to 5 is in hours. 1680 to 600 is in barrels. So this is going to be a negative quantity of something in barrels per hour. It's a volumetric flow rate. What do you get, James, for the slope?
Negative 360.
Barrels per hour. Okay? So when you're doing these kinds of problems, consider the units because later in the problem, I guarantee you the units will help you out. Okay? So really think about the units when you're doing stuff like this. Now, that's the slope. What would the y-intercept be? Anybody get the y-intercept? The b value? James?
I took 1,680, which was at 2 p.m. I took the slope, multiplied by -2, and I got 1,680 plus 720 equals 2,400.
Yeah, so you tacked on the amount that you would be missing in a sense. Now, you can do that, or honestly, James, you could also just do this. That you did it the way I'd like to see you do it because it's like a visual understanding of what's happening per hour. You could also just do this, right? Plug in one of your points and solve for b. Okay, either way works. So you could just use this function, plug in a point, and solve for b. Now, on the other hand, what'd you get again? What was the 2,400. Perfect. So what is that significance first? 2,400. What is that actually telling us?
How much? Oh,
Yeah.
how much you spent?
Yeah, how much you started with. So that's kind of answering what part of the problem already. Yeah, part B. Okay, it says how many barrels are in the tank at noon. So it's good to see that. So if you figured out what the y-intercept was because you understood the context of the problem, and James said, you know what, I'm going to realize that we're going to have to add a certain amount to this because 2 hours have gone by. Well, what's that amount? That amount's 720 because you're losing 360 gallons every hour. If you're losing 360 gallons every hour, you've lost 720 gallons after 2 hours. So he's adding the 720 to the 1680 there. Okay? Now, what's another way you could have done this? And it might not be obvious, but you could have thought of this and started with this, right? You could have said this. It's the volume as a function of time. And you could say, again, it's definitely linear with some starting value. So you could have started with that statement, which is kind of like y equals mx plus b, right? Do we all see how that's y equals mx plus b right there? Y is v of t. T is really just x. So that's y equals mx plus b. Now, we could have just simply plugged in these 2 points and it automatically solved with a matrix. And it's just a different way to do it, and it might be useful down the road, so I thought I'd show you for this one. So plug in 1,680 gallons of fuel. The slope is unknown. After how long? 2 hours. And then plug in 600 here. Slope is unknown. After how long? Well, 5 hours. And you have 2 variables and 2 equations. You can plug this right into a matrix and do what looks like 2, 1, 1680, 5, 1, 600. And just solve with the matrix to get m and b. Does that make sense? Does that make sense why I'm saying that? Okay. It's another approach to take. And it might be useful. You know when it might be useful? If you're not just given, you don't just have slope, if you have a third variable also, then it's a little bit annoying to solve a system like that. So you're technically solving a system when you do this, by the way, on the left here. This is kind of like a system. You have 2 points, so you're coming up with a solution for the system. The overall equation, that's what you're doing over here as well. But when you have 3 variables, it might get a little bit more difficult, so it's good to know. Anyhow, so we get the function itself. All right? So let's write that down. The volume function, v of t, is equal to negative 360t plus 2400. So we have parts A and we have part B already. Part B, this is the value at noon, the starting value, when time is equal to 0. How do we do part C? Part C. So part C says, what time will the tank be empty? When the tank's empty, how much volume is in the tank when it's empty? 0. So what do we do, Em? If the volume is 0, right? When the tank's empty, what do I do with this? Be careful, because 0 for t is 0 time has elapsed. That's the beginning of the problem. And at the beginning of the problem, there's 2,400 gallons, right? We want to know when the volume is 0. Where do you see volume? Yes. So the volume is 0 at what time? Isn't that the question? So we solve for t, okay? Because we're looking for time, we want to leave that alone because we know the volume is 0 and we plug in 0 for v. Remember, it's v of t. It's the volume as a function of time. So if we say that the volume is 0, we can locate that time by solving for t because they are functions of one another. Okay. What do you get? And give me an exact time using like the AM, PM system, not like decimal. Jeff?
6:20 p.m.
6?
20.
20 or it's 6.66, right? Isn't the answer? That's not 6. There you go. 6:40. So it's 6 2/3, so 6:40 p.m. The answer you get for time is 6.6 repeating, which is 6 2/3. 2/3 of an hour, 2/3 of 60 is 40 minutes. So 6:40 p.m. All right? So what I want you to do for a little while, you have about 15, 20 minutes. There's a few practice problems I want you to work on together. So work with maybe 1 or 2 other people at most. It's under documents and handouts. I'm going to pull it up on the overhead now, and then maybe we'll go over them as we go through. So look under documents.